Linear momentum of a body is the product of the mass and the velocity of the body. So P, which is linear momentum, is given as mv, mass multiplied by the velocity of a body. So it depends on the mass as well as the velocity of the body. That is linear momentum. All right, let's look at law of conservation of linear momentum, and let's begin with what conservation is in an isolated system. Consider this box and this box. This one contains two individuals, Mr. A and Mr. B. Mr. A is having a sum of 500. Mr. B is having a sum of 300. If you sum the money they have, if you add it up, Mr. A and B are having a total of 800 in this box. Now, let's say later, at any later time, Mr. A chooses to give 100 to Mr. B, and they are having, Mr. A will be having 400 because he has given 100 to Mr. B. So Mr. B will be having 400 as well. So if you add the amount inside this box again, you're still going to have 800. You see that the total here is still the same regardless of the changes that happen inside. And that is what conservation is. Conservation is when what is gained by one, when what is lost by one is gained by the other, in such that when you add everything up, you still get the same total. That is conservation. So let's take this understanding to momentum. When two bodies collide, the sum of their initial momentum before the collision, which will be m1u1 plus or minus m2u2, depending on their direction, should be equal to the sum of their momentum after the collision. So this m1u1 stands for the momentum of the first body before collision, m2u2 the momentum of the second body before collision, and here is the momentum of the first body after collision, the momentum of the second body after the collision. So when you sum them, they should be equal in an isolated system, when two bodies collide in an isolated system. So this is the formula we're going to be using to solve problems. So the plus and minus here, because momentum is a vector quantity, okay, their directions will determine which one we're going to use. So basically, when they are in opposite direction, use minus. When they are going in the same direction, use plus. So let's go straight and solve this question. A body of mass 12 kg traveling at 4.2 meters per second. So let's take that as our m1. So our m1 is 12 kg and our u1 is 4.2 meters per second. Collide with a second body of mass, this. So that is our m2. Our m2 is 18 kg, and at rest means our u2 is 0 meters per second or meter per second. Calculate their common velocity if the two bodies coalesce after collision. That means the two bodies joined together and started moving with the same velocity after the collision. Now, the implication is that the final velocity of the first body is going to be equal to the final velocity of the second body, because the two bodies coalesce, they stick together and started moving. So we just call it V, since it's the same for them. Since V1 will be equal to V2, let's just call it V. All right, we're going to substitute values in this equation and solve. So our M1 is 12, so we have 12 times U1, 4.2, then plus M2 is 18 times 0, because U2 is 0, was at rest. This equals M1, which is 12, times V. Of course, we are not going to use V1 like I've explained, plus M2 is 18 multiplied by V. So when we times 12 and 4.2, we're going to get 50.4 plus 18 times 0 is 0 equals 12V plus 18V. And this will be 50.4 equals, this will give us 30V here. Therefore, if you make this subject of formula, it's going to be 50.4 divided by 30, and that equals 50 0.4 divided by 30, that's 1.68. So our V equals 1.68 meters per second. So that's their common velocity. Common velocity 1.68, and that is option D, 1.67 in one decimal place.